Writing the equation of a sine or cosine function given its graph, problem type 1. When you think about a sine function, there are 4 different places that you have a parameter that you can vary, right? Y equals a times the sine of bx plus c plus d, right? A gives you the amplitude. The period of the graph is 2 pi divided by b. C gives you the phase shift, and D gives you the vertical shift. And you can do the same thing with cosine as well. The first rule of thumb is to look at the y-intercept. If the y-intercept of the graph in question is a peak or a trough, you're going to use a cosine. And when you're going to use a cosine, the phase shift is always going to be 0. If it is anything else, you'll use a sine. And you can figure out from there if there's a phase shift, and if there is, what it must be. Right? Let's look at a graph as a way of thinking about it. So here we have a graph of something that's clearly a sine wave. It exhibits that up and down pattern that you're very accustomed to as seeing with a sine wave. The first thing I notice looking at this sine wave is that vertically the peaks are at +3, and at the bottom the troughs are at -3. Right? That's symmetric, and that's important. That means that there's no vertical shift. Right? The next thing I look at is the y-intercept. The y-intercept in this case is right at 0. Right? So the y-intercept is in the center. That means we're going to use a sine curve. And there is no phase shift. Right? 2 important things to keep in mind. Now, since there is no vertical shift, the value up here, the height that we get to, is the amplitude of the function. So in this case, a is going to be 3. The last thing we want to look at is the period. So if I switch over to my highlighter for a moment, think about one complete cycle. In this case, the cycle starts at 0, which is always a convenient place to start, and it ends at 3 pi. So the period here is 3 pi. And the period is 2 pi over b. So I can multiply both sides of this equation by b, and then divide by 3 pi to get that b must be 2/3. The very last thing that I want to notice is that this particular curve starts by going downward instead of upward. Right? That's the mirror of what we normally think of as a sine wave. Right? Sine usually is shapes that look like that. So to deal with that, we simply take the negative of our amplitude. Right? There's all of our pieces. I didn't leave myself enough space to write the equation, so let me get rid of some of this stuff. And again, we determined first that it was going to be sine, so y equals a times the sine of b x plus c plus d. We determined that there was no phase shift, c is 0. We determined there was no vertical shift, d is 0. The amplitude we came up with is -3. And since the period is 3 pi, 2 pi divided by 3 pi gives me 2/3 as the value of b. So just taking all that information we found, putting it into the equation, and I get that the graph of this function is y equals -3 times the sine of 2/3 x.